Hello YouTube. Today we're going to be talking about randomization when it comes to statistics. And a few things that we need to know about randomization. Pretty much it's saying, do the samples differ more than what is reasonable given mere chance? So do they really different, or are the two samples that we're comparing really different, or is it just happen to be the same by chance? Now randomization is the process by which we can determine if it truly was random and see if our results are valid. So what we're going to do is we're going to look at two samples and infer that the two populations from which they are derived are actually different. Again, that's kind of saying we're going to compare the two samples and their respective populations and see if they are really different. So here's an example, just something came up with. So you have women and men and their GPAs. So you have a sample size of 5 total, but 3 are women and 2 are men. So here their GPAs 4.0, 3.7, 2.7, 3.0, and 3.0. So what we're going to do is we're going to calculate the average of each. And we have 3.46 average for the women and obviously 3 for the men. So the question is, or after you take the sample mean difference, so you compare this difference in the means and you get 0.46. So are women, you could say, argue that they're smarter by 0.46 in their GPA. The question is, are they really different? Is there really a difference here? Well, to really test that, we will use randomization. Now you're probably already thinking, it's like, well, you just happen to pick, two men who had a 3.0 GPA. They might have had higher or lower. And same thing with the women GPA. You say, well, you just picked the smartest girl, and then stuff like that. So this is what we're going to be statistically analyzing to prove, or not prove, but argue for your justifications for those reasons. So then you take, for randomization, we could take these 5 people, we'll put them in random groups of 3, and 2 people in random group B. Now to do that, we pick random, so you could pick any one of these combinations, and one of them could be a man, and 2 of them could be women. And then you can have 2 men and 1 woman. Things like that. So it mixes up it kind of shuffles the deck rather than categorizing. So how many combinations, how many different ways can we do this? Well, we can do this in 10 ways. If we were to label the category of women to be group A and group B, well, they don't really necessarily mean man and women, but we're just going to make 2 separate categories and reorganize the data. And then we said that a 4.0 GPA is A, 3.7 is B, 2.7 is C, 3.0 is D, and this other 3.0 is E. So now we'll make this chart. Again, following that randomization, we made two rows, or 2 columns, and we just randomly picked, and there are 10 different ways to do this, A, B, C, D, E, then A, B, D, C, E. So we're using all of them. Remember, no duplicates here, obviously. And we pretty much organize the data. Now we want to figure out the average data, or the average mean for each section. So we have the average mean for the average of A plus B plus C would be 3.46, and then the average of DE would be 3, so that's just the first one. So then we have the average of AD, or ABD, so that's 4.0, 3.7, and 3, and we get the average to be 3.56, and then we want to compare it to C and E, which would be 2.7, and 3.0, which would be 2.85 average. And you do the same thing going all the way down. You compare the average of each one in group A and B, and then you take the difference. Now I'm going to do all the difference calculations real quick, so boom, here they are. So now comes the question, which are different? Which are greater than that 0.46? So we have 0.46 is greater than or equal to, so that does count. We have 0.71, which is greater than or equal to 0.46. We also have this one as well. And these are negative, so not quite negative, negative, negative. But this one is, should be 0.95. Yeah, that should count because the difference. Okay, so that means we have 40%. So 4 out of 10, because there are 10 combinations, and we chose 4 of them, that are greater than or equal to 0.46. Now, what does that mean, kind of? Well, pretty much it's saying that only 40% of the time maybe this is true for this sample. And this is pretty much averaging out the effects of all the other outcomes by categorizing men and women, by putting that barrier there. But one thing I do want to mention when I was circling in purple, this, since you could have y2 minus y1, it could also be negative 0.46, so that's why I shouldn't have said, oh, that's negative, that's negative, that's negative. It's because it's 0.12 or negative 0.12. It's smaller than that 0.46, plus or minus 0.46, pretty much. So that pretty much covers randomization. Hope that kind of helped you understand why we you kind of shuffle the deck is kind of the best analogy to do, rather than splitting everything up and then you have something that might be lenient towards one side or another. If you shuffle the deck, it makes it more fair, and that's kind of what randomization does here.